Hey guys, sorry I couldn't make it to class today. I'm going to put together a video or two that goes over, introduces identities, which we're starting today. So in OneNote, under Unit 4, Identities, there should be a few files in there. We're going to go through a few of those together today, kind of lay the groundwork for identities, and then tomorrow we'll kind of hit the ground running with that. So, under the Unit 4 Identities tab in OneNote, there should be a file called Identities Day 1 Notes. And in there, the first slide is a warm-up. It's some algebra review. So pause this video, take a few minutes, go through those 4 questions, those 4 algebra review questions. And then once you're finished with those, come back here to the video and check your answers. So here are the answers to the warm-up. Number 1 is just a FOIL problem. Number 2, you can write that as x plus 5 times x plus 5. FOIL that. Number 3, you need a common denominator in order to add 2 fractions. So I multiplied the first fraction by 1, written as x plus 3 over x plus 3. Same idea with the second fraction. Make sure you distribute in the numerators, and then once the denominators are the same, you can add those 2 fractions together. Number 4 is just distributing. So those are some algebra skills that we'll be using over the next several days as we go through identities. So you might be asking what an identity is. And you're familiar with some identities. For example, if you have, say, 2, see if my marker's going to be working, 2 times, say, x plus 4 plus x plus 2 equals, say, 3x plus 10. On the left side, if you simplify that by distributing the 2, you have 2x plus 8 plus x plus 2. Combined like terms, you get 3x plus 10, which is the same thing we have on the right side. That's kind of the idea behind a trig identity. A trig identity, for example, might be tangent of theta times tangent theta plus cotangent theta is equal to secant squared theta, where the idea is to simplify the left-hand side and get that to be equal to the right-hand side. Similar to what we did over here, simplify the left-hand side, got 3x plus 10, matches the right-hand side of 3x plus 10. Same idea here. It's going to be an equation that not we're solving, but an equation that's going to be true for all values of the variable. So this expression is going to be true no matter what x is. Any x value is going to make that expression true. Same idea over here. No matter what theta is, this expression is always going to be true. And we'll probably touch base with this one to start tomorrow. But before getting into some of the identities, we need to get some basic identities and some strategies. So what we're going to be looking at today is filling out this table. We're not actually going to fill out this one. We're going to look at one that's a little bit different than this, has the same ideas. So one of the goals for today is to get this table of trig identities completely filled out. There's 9, 18, 20 of these we're going to be looking at. And once we get these filled in, then we'll kind of go over those. So to fill those in, we're going to go and do this. So this is basically going with the x, y, r stuff that we know from our very early trig. We know sine of an angle is equal to y over r. We know cosine of an angle is x over r. And we know tangent is y over x. And we also have then cosecant is r over y. Secant is r over x. And cotangent is x over y. So what we're asked to do here is using x, y, and r, where x, y is going to be pointed on terminal sides, so on and so forth. We want to write 3 sets of reciprocals. And we want the product of each pair of reciprocals to equal to 1. And then replace the ratios with the known trig function. So for example, we could take the reciprocal x times, let's actually do y over x times its reciprocal would be x over y. And if we multiply them together, we get 1. So if we replace those with the known trig functions, y over x, we know, is tangent. So tangent of theta times x over y is cotangent. So tangent of theta times cotangent theta is equal to 1. That's one of our basic reciprocal identities. We're going to put that in the table in just a little bit. If we do the other combinations, if we do y over r times r over y equals 1. Well, we know y over r is sine, r over y is cosecant. If we multiply those together, we get 1. And then the other combination, if we do x over r times r over x equals 1. X over r is cosine. And r over x is secant. So cosine times secant is equal to 1. So we're going to take these three ideas, these three reciprocal identities, we're going to put those three into that table. So if you go to the table of trig identities, we have these reciprocal identities. We're going to put the three that we just found in this table here. So we're going to have tangent times cotangent is equal to 1. We'll have sine times cosecant is equal to 1. And we'll have cosine times secant is equal to 1. And if we do a little bit of algebra with each of these, we can get two different variations. And the variations that you're going to see are going to look very familiar. So we take this expression and divide both sides by cotangent. So divide both sides of this equation by cotangent. On the left-hand side, when we divide by cotangent, the cotangents cancel out. So we're left with just tangent. And on the right-hand side, if we divide by tangent, we end up with tangent of theta is equal to 1 over cotangent. And that's something you already know. You know tangent and cotangent are reciprocals. You know tangent is 1 over cotangent. And if we do the same thing with this equation and divide both sides by tangent, then we end up with cotangent of theta is equal to 1 over tangent. Again, this is something you're familiar with already. This is, if you wanted to find a cotangent of 58 degrees in the calculator, you would do 1 over the tangent of 58 degrees. So you know tangent and cotangent are reciprocals. If we do the same idea with the other two reciprocal identities, we're going to get sine is 1 over cosecant. And we can also get cosecant is 1 over sine. And then we can get, for that last one, cosine is equal to 1 over secant. And secant is 1 over cosine. So we're getting there with getting that table filled out. Okay. We're going to go over to the identities proof packet again and get a few more identities, see where these came from. So these came from, again, just using the x, y, and r idea with the idea we're going to multiply two reciprocals, and we end up with those, and that gives us then the other variations from that table. Scroll down a little bit. So it says using the ratio sine over cosine as a starting point, define the ratio in terms of x, y, and r, simplify, and come up with an equivalent trig function that's equal to the quotient. So they want us to start with sine over cosine and rewrite those in terms of x's, y's, and r's. So sine is y over r, cosine is x over r. since we're dividing fractions, we know that division with a fraction is the same thing as multiplying by the reciprocal. So instead of dividing by x over r, we can multiply by r over x. When we multiply those two together, r's cancel, left with y over x, which we know is the tangent of theta. So altogether, this gives us sine over cosine is equal to tangent. This is a big one, guys. This one comes up all the time. You'll end up memorizing this one without even trying to. That's going to be one of our ratio identities. If we repeat that process, starting with cosine over sine, again, sine over cosine and cosine over sine are reciprocals. Well, we know the reciprocal of tangent is cotangent. So if you want to pause the video and verify that cosine over sine is equal to cotangent using x's, y's, and r's, you can go ahead and do that. I'm going to pause it and give you a chance, and I'll put it here and you can come back and check. So these two identities we're going to put in that table of trig identities. So go to that table of trig identities, and our ratio identities, one of them is sine over cosine is equal to tangent. And we're going to have cosine over sine is equal to cotangent. We're not going to worry about any variations for those two. Alright, I'm going to do one more piece yet to get these Pythagorean identities up top. So go to the identities proof packet again. The last page. We're going to state the Pythagorean theorem in terms of x's, y's, and r's. So in terms of x's, y's, and r's, we have x squared plus y squared equals r squared. Then the directions say to divide both sides of the equation by r squared. So we can rewrite that as x squared over r squared plus y squared over r squared is equal to r squared over r squared. We're used to finding a common denominator and putting two fractions together as one. Here we're just taking that one fraction with the denominator and splitting it up into two. So it works both ways. So this is going to be x over r squared plus y over r squared. Anything divided by itself is just 1. And then replacing these with our trig functions, we know x over r is cosine. So cosine squared plus y over r is sine. So you have sine squared. And that's going to be equal to 1. Guys, this is another big identity. Sine squared plus cosine squared, or cosine squared plus sine squared, is equal to 1. Like you do the same thing, follow the same process, and look at the last two, and see if you can come up with the last two trig identities. So pause the video, work on 2 and 3, following the directions in the example from 1, and see if you can come up with the other two trig identities. Okay, hopefully you're able to get, for the second one, 1 plus tangent squared equals secant squared. And for the third one, cotangent squared plus 1, or 1 plus cotangent squared, the order there doesn't matter, is equal to cosecant squared. So these three are our three Pythagorean identities. So you're going to go to the table and fill that out in the table. So you have sine squared plus cosine, sine squared plus cosine squared equals 1, 1 plus tangent squared equals secant squared, and cotangent squared plus 1 is equal to cosecant squared. And I'm going to just do the variations for those. Basically for sine squared, I'm going to subtract, for the first equation, I'm going to subtract cosine squared from both sides. That's one of the variations. And I'm going to subtract sine squared from both sides. That's the other variation. Do the same thing for the 1 plus tangent squared equals secant squared. And the cotangent squared plus 1 is equal to cosecant squared. So if you want to pause it and try those, you can. And then when you unpause, I'll have... Alright, so there's the